Alright everyone, this is section 2.2 from our homework. This is math 1530, and you should have this in your possession. This is what I gave at the conclusion of our class on this past Thursday, June 2nd. So everyone should have this set of notes. I want to start off with your calculator. One of the things in your calculator for this section that has to happen, your calculator must have the diagnostic on. So I'm going to go through what that means in your calculator. So in my calculator, I need to get to this catalog function here. It's in yellow or kind of orangey, so I'm going to use the second function. I'm going to press second and 0, and that brings up the catalog. These are all the functions of the calculator. It's like the table of contents. And so what I'm going to do is scroll down. I'm just going to use the down button. And when I get to diagnostics, notice how everything is in alphabetical order. So this is all the things that the calculator will do. Here in this diagnostics off, diagnostics on, I need to ensure that it is on. So notice how my cursor is on the diagnostic on. I need to press enter to select it. The calculator is asking me a question right now. Do you want to turn it on? I'm going to say yes by pressing enter. And now that's done. Now, why is this important? We're going to see later as we find our what's called correlation coefficient. If this were not on, then you wouldn't see this, the answers that we're looking for in the lesson, you wouldn't see it show up on your calculator. And so that's how we make sure that that feature is existing in our calculator. Alright, so let's get right into it. Today is this is section 2.2. Today is the 3rd, June 3rd, 2022, and we're going to jump right into it. Remember, we're going to define some things, give a little bit of theory, do some math as we go through the notes. So the first question says, describe the range of values for the correlation coefficient. So let's jump right into it. What is a correlation coefficient? So outside of math, the word correlation means relationship, how things relate to one another, how they associate to one another. The word coefficient outside of math loosely means how things work together, how two parts work together. And so in statistics, the word correlation coefficient implies or refers to the association of two quantities. There is a value that represents that association, and we call it the correlation coefficient. So the correlation coefficient is a value that represents the strength of the relationship between two quantities. The variable to represent that is the variable R. R is the correlation coefficient. So the question is asking us about the range of it. It goes from what to what. And notice how the answer choices are stated. The range of values for the correlation coefficient is -1 to 1. That means it goes as far as -1 for a strong negative relationship, all the way to +1 for a strong positive relationship. So the further I get closer to either -1 or +1, the stronger the relationship. The relationship can be positive or negative. But this word inclusive means that I can include any of the numbers that are between -1 and +1, and I also can include -1 and +1. So a correlation coefficient could be -1 according to this answer choice. It could be it could be -0.75. It could be 0. It could be +1, because inclusive means I can include these values. The range of values for the correlation coefficient is 0 to 1 inclusive. Well, I just stated for you that the correlation coefficient is this value that represents the strength of a relationship of two quantities. It can be negative, or positive. Well, if it can be negative or positive, that means that this range in answer choice B violates our definition. If it can be negative or positive, this range that is stated here in answer choice C violates it, because this implies that the correlation coefficient can only be 0 or positive values up to positive 1, and that's not true. Now that leaves us with these two options, which differ in whether or not I can include -1 and 1 inclusive, or not to include -1 and 1. Well, the correlation coefficient can be the number -1. It can be the number 1, or it can be all the decimals in between that. So this is the violation here. So by definition, the correlation coefficient is a value that represents the strength of a relationship between two quantities. We denote it by the letter R, lowercase r. It can be negative or positive, and its range is from -1 to +1 inclusively. Alright. Number 2. Now that we know that, let's look at what number 2 says. Which value of R, the correlation coefficient, indicates a strong correlation? Would it be R equals 0 and 7.735, or R equals -0.873? Explain your reasoning. So before we even look at the answer choices, let's compare these two values. I see one clearly is positive, one clearly is negative. One is very much close to -1. One is close to +1. But when I compare or to determine their strength, I need to compare what's called their absolute values. So here in these answer choices, you see these vertical bars here, and they mean the absolute value of -0.873. The absolute value of 0.735. And that's just to say how far is it away from 0. So let's first talk about these bars. Just a reminder that these bars are absolute value. Alright, so when I find the absolute value of a number, I'm really finding how far is this number away from 0. Well, -0.873 is this many units away from 0. So in other words, it's just the positive of that value. 0.735 is this many units away from 0, 0.735 units away, because absolute value represents a distance. So the question is asking which one is stronger. So first thing I look at, I'm taking the absolute value. Answer choice A says, well, -0.873 represents a stronger correlation because its absolute value is greater than the absolute value of 0.735. In other words, it is farther away from 0, it has a greater distance from 0 than this other value. Okay, so let's keep that in our back pocket. But let's look here at answer choice B. R equals 0.735 represents a stronger relationship because it has this number here is greater than the absolute value of it is greater than this one. Well, that's not a true statement, because the absolute value of -0.873 is actually a positive 0.873, and a positive 0.873 is much bigger than a positive 0.735. So this this would be not true. This is not a stronger relationship because this value, absolute value, is much larger. So B is not our answer. This is not a true statement, the entire line. This is true, but this is not. This number is greater than, this absolute value is greater than this one. So the stronger relationship lies here. Okay, let's look at C. R equals 0.735 represents a stronger correlation because this value, 0.735, is greater than negative 0.873. This is actually a true statement. However, when I determine which is stronger, I have to consider their absolute value. So though this is true, though this positive value is greater than this negative, its absolute value is not greater. So C is not my answer. Let's talk about why. The absolute value of 0.735 is not greater than the absolute value of negative 0.873. R equals negative 0.873 represents a stronger correlation because 0.735 is greater than negative 0.873. Again, this is true. However, the stronger correlation lies in the absolute value, the comparison of the absolute value. And so though this is true, it doesn't represent the stronger correlation. D is not our answer. A is our answer. So let's revisit why A is our answer. So given a problem like this, the first thing you need to do is find the absolute value of each number. Compare them. And then the determination is this: the greater the absolute value, the stronger the relationship, the stronger the correlation. The greater absolute value has the stronger correlation. Okay? So in other words, the absolute value of 0.735 is 0.735, but the absolute value of negative 0.873 is positive 0.873. Since positive 0.873 is greater than 0.735, then it has a stronger correlation, a stronger relationship. Okay? Number 3. If data A has a correlation coefficient R of negative 0.991 and data B has a correlation coefficient of R 0.991, which correlation is correct? Before we look at the answer choices, let's use what we did here to align these two. I see R is negative 0.991. What is the absolute value of that number? It will be positive 0.991. What is the absolute value of 0.991? It will be 0.991. When I compare them, just like we said here, compare them, they are equal. So that means that their correlation is equal. Let's look at the answer choices. Data A has a weaker correlation than data B. Not true if they are equal. Data A and B have the same strength in linear correlation. That's true because they are equal. Answer choice C, data A has a stronger linear correlation than data B. Not true. They have the same correlation. I used this. I found their absolute value, then I compared them. The greater absolute value has the stronger correlation, where they are the same, so they have equal or the same strength in correlation. Answer choice B is our answer. Right? Let's keep going. Remember, you're able to pause this video at your leisure to go back and listen to it again if you need to. Given the supply of commodity X and the price of commodity Y, would you expect a positive correlation, a negative correlation, or no correlation? So let's start off by talking about, so we've defined correlation, we know what it is. We also see that when I determine strength, I look at the absolute value of the correlation coefficient. And then now we're coming to that there are types of correlation. There can be a positive correlation, that's relationship. There can be a negative correlation, or there can be no correlation. Let's look at a visual of each type. So this goes back to, remember from school, from the coordinate plane. So I'm going to sketch a little coordinate plane. I'm going to put this one here. This is my x-axis, this is my y-axis. Okay? If x represents the supply, this is my supply, y represents my price or cost. I have a positive correlation when my line appears to rise. That's positive. Let's talk about what's happening in a positive correlation. As the supply increases, the price also increases. Okay? As the supply increases, the price increases. That's why everything goes up. So as my supply goes up, that's from left to right, my price also increases. Well, in general, in business, when I have a lot of supply, then my price doesn't usually go up because I'm trying to move the product. So positive correlation is this: the price goes up, the supply goes up, the price goes up. Then that means visually the line increases and I get a positive correlation. So for a negative says, here's my supply, here's my price. If positive goes up, that means negative does what, y'all? Goes down. That's negative. Well, what's happening in a negative correlation situation? As my supply goes up, notice how when I move from the left to the right, my line is going, I'm getting further away from what would be zero. So the supply is increasing. I get more and more supply. Nothing's moving. I'm not selling anything. Well, if nothing's moving, I need to bring the price down. I need to bring that price down so I can move some supply. So when I have a lot of supply, my price actually goes down. So this problem is asking us to estimate or predict what would happen, which one of these could represent a supply and price situation. Well, if my supply increases, I would expect my price to decrease. And when that happens, I get this negative correlation. When the supply increases, that would be my X, then the price should decrease. And that would be a negative correlation. Conversely, when my price increases and when my supply increases and the price goes up, then I get a positive situation. But this question is asking in general, like, what would happen if, what generally does happen? If I get a whole lot of supply, I want to bring the price down so I can move it. Okay? Alright, number 5. I'm going to be using the calculator quite a bit on here, so make sure you have your calculator available because I'm going to be using that quite a bit. Alright, here we go. Number 5 says, the data below are temperatures on randomly chosen days during the summer class and the number of absences on those days. Calculate the correlation coefficient. That's our task. They want you to find R. In the previous problem, R was given to us. We have to find it. Look, we have a list. So we're going to our calculator. I'm going to jot down what the keystrokes are, and then I'm going to perform that. So in my calculator, the first thing I want to do is enter into the list. So I'm press stat, option 1, enter data. Now notice we have 2 sets of data, so we're going in L1 and L2, and L1 and L2. Okay. So we're going to put that in there. All right. Okay. I'm sorry, y'all. I'm putting my data into my list. 80, 105, 85. Okay. So once I put the data in, we know this time what's different is I'm still going to go back to stat, so press stat. But this time I want to tab over to calc, so that's the same from last section, tab to calc. But this time I don't want option 1, I actually want option 4. So I want option 4, and that should say line, it looks like Lin, but it's line rig. Okay, and that stands for linear regression, and so we want option 4. And then I'm going to tell it, because the calculator knows that the only way to do linear regression is you've got to have something in both lists. You don't have to tell it on this one to pull from both lists. It knows to do that. But if you were to put in L1 and L2, that would certainly be fine. And so I get, and then I'm going to record from my calculator, record value for R. Okay. All right. So now let's see that happening in real time. Stat, option 1. Here's my list. I put that in there. Stat, tab over to calc. I want option 4 this time. Lin reg or line reg. Option 4. And I'm going to press enter. Alright, so they give us a lot of information. It gives us the correlation coefficient is what we're looking for here. And we're going to round that based off our answer choices. It looks like they're being rounded to the nearest thousands. Tenths, hundredths, thousandths place. Okay? And 0.980 will be our answer. So we're recording that and choosing answer choice C. Feel free to pause this to try it again on your own to make sure that you're comfortable with the keystrokes. Now, let's interpret what we have. Number 6 says, what does it mean to say correlation does not imply causation? Well, let's remember what the word correlation means. Correlation means relationship or association. How things are associated or related to one another. Causation, the root word being cause, right, implies a cause and effect relationship. So this phrase says that relationship or association does not always mean that the two quantities are in a cause and effect relationship. So what the answer choices are asking is which one defines that technically. Let's look at answer choice A. Answer choice A says, it seems like it's not big enough, y'all. Oh, it's too big. Okay. Answer choice A says the fact that two variables are strongly correlated implies a cause and effect relationship between the two variables. Well, that's exactly what this is not saying. This is saying that because things have a relationship does not always mean they have a cause and effect connection. Answer choice A is the contradiction to that. Then that's not our answer. Here's the violation. It implies that. It does not imply that. That's exactly what this says. It does not imply that. Answer choice B. Two variables that have a cause and effect relationship are never correlated. Well, that's not true. It is possible for two variables or two quantities who have a relationship and it's caused by their cause and effect relationship. Okay? So it's never correlated. It's too strong of verbiage. Alright. C says the fact that two variables or quantities are strongly correlated or related, have an association, does not in itself imply that they are in a cause and effect relationship between the two variables. That's exactly what this is saying. It means that though they are strongly related, though they are strongly associated to one another, they may not imply that they actually have much of a independent and dependent relationship. One causes the other. C is our answer. D says two variables can only be strongly correlated if there existed a cause and effect relationship between the variables. D is the direct contradiction to B, and they're both incorrect. This one says they're never correlated. This one says it only happens if they are correlated, and that's not true. If they existed. Okay. All right. Number 7. Identify the explanatory variable and the response variable. Well, what are those? There's 2 new words. To be explanatory and response, one makes the other happen. If I'm responding to what is explanatory, what happens regardless. So we kind of call that explanatory variable our independent variable. Independent. And then this one is our dependent variable. So let's read the context. A farmer wants to determine if the temperature received by similar crops can be used to predict the harvest of the crops. So you're really being asked what relies on the other, or what makes the other happen. This is indeed a cause and effect type of relationship. The cause is independent. It makes the effect happen. So what's the cause here? Or what is independent? Let me give you a moment to think about that. If you said that the temperature received is independent or explanatory, then you are correct. The temperature. Because the temperature will affect what? The harvest crop. So the temperature is independent and the harvest is dependent. It depends on the temperature. The temperature doesn't depend on the harvest. Alright? Let's continue. Alright. Number 8. It says the ages and years of 10 men and their systolic blood pressure in millimeters of mercury are shown in the attached table with the sample correlation coefficient of 0.899. Let's talk right there. Is this a strong relationship? Do they have a strong association? They kind of do. One is positive and it's very close to 1. Remember from problem number 1, the closer we get to 1, a positive 1, the stronger the relationship. Alright, remove the data entry for the man who is 49 years old and has a systolic pressure of 199 millimeters of mercury from the data set and find the new correlation coefficient. So, describe how this affects the correlation. Use technology. What we know is that the existing relationship or correlation, so the original R is 0.899. We're told to take out this entry. I'm just going to alleviate that from here. I'm going to go to my calculator. So I have my list in my calculator. Notice I have omitted 49 and 199. I've omitted 49 and 199 from here. So I go from 45 to 65. So I'm going to do the keystrokes. Stat, calc, option 4, enter. And I see that my new correlation coefficient, is 0.9663 and some change over there. See what that says. Okay, so I'm going to record that to 3 decimal places. So I'm going to go here to the 4th one. That's a 3. It's not strong enough to move this 6 to a 7. So I'm recording. So my new correlation coefficient is 0.966. So the new correlation coefficient are 0.966. Okay. I think it probably should have gone right there, but it's okay as long as we got our answer, y'all. All right. So the I thought it was going to ask us to describe how it affects it, but I think it just shows us here. It's stronger. Do y'all see how it's stronger though? Let's put that here. The correlation is now stronger because the number went from 0.899 to 0.966. So it got closer to 1. So it has a stronger relationship now. All right, let's go to number 9. So two variables have a positive correlation. Is the slope of the regression line for the variables positive or negative? So let's start with this first statement here. Two variables have a positive linear correlation. Two quantities have a positive linear correlation. Remember from our previous problem, when a correlation is positive, that means X is increasing, Y is increasing. Is the slope, that means is the steepness of this line, of this regression line, that's that line here, positive or is it negative? It's asking, are the values, there's a fraction that can be made for the slope. So the slope can be made by this fraction, y over x. The question is asking, is this fraction going to be positive or negative in a positive relationship? Well, in order for a fraction to be positive, two things have to occur. Either I have a positive over a positive, or I have a negative divided by a negative. That's the only way I can get positive. Everything either got to be the same sign in order for me to get a positive. Well, let's see what that means to our answer choices. The slope, or this ratio, is positive. As the independent variable increases, that will be x, the dependent variable tends to increase, that will be y. As everything goes up, as one variable goes up, the other goes up. That's pretty true. But let's look at the others to see if we hear some violations. The slope is negative. Let's stop right there. Is the line rising or is it falling in our graphic? It definitely appears to be rising. So if the line is rising, then it's not negative. Let's also look at y. As the independent variable increases, goes up, the dependent variable tends to increase, go up. That if both of these things are going up, this can't be negative. So the violation happens here. This is a true statement, y'all. This is the violation. Let's look at C. The slope is negative. Well, we already established that it's not negative, but let's look at what's happening here. So that's the violation. As the independent variable increases, the dependent variable decreases. Well, that's true in a negative slope. So though this is true and this is true, it is not true for this problem. So it's not our answer. The slope is positive. Oh, positive, that's true. But let's see if the reasoning is right. As the independent variable increases, yes, the dependent variable tends to decrease. Oh, no. Violation. So the most appropriate answer lives here in A. Alright, let's look at number 10. Given a set of data and a corresponding regression line. So, what do they mean? Given a set of data, this is a set of data, and a linear regression line, that would be a graph, something like this. Okay? Describe all the values of X that provide meaningful predictions for Y. I'm going to highlight that phrase, meaningful predictions. What does that really mean for us? Okay. Predictions, let's read the answer choices. Predictions values are meaningful only for X values that are not included in the original data set. In other words, meaningful means that it makes sense to the data. It makes sense to the situation. It's not an outlier. It kind of lives in what we're talking about. And so if I make a prediction for Y, I need my X values to be included in the data, because if they're not included, then it's not meaningful. It doesn't mean anything to the data. So right here, let's read it again. Prediction values are meaningful only for X values that are not included. Well, right there, I need them to be included. That's a violation. Prediction values are meaningful for X values in or close to the range of the original data. That's kind of what we want, because that means that the prediction that I make lives inside of the data. It would make sense for the data. So we want it to be either in or really close to the range of the data. We don't really want to use an outlier. Let's look at C, see why that's wrong. Predictions are meaningful for all X values that are realistic in the context of the original data set. Well, it may be realistic. However, if the values are not included in the range, they're still not meaningful. So right here, though realistic in the context, if the values are not in range, they are not meaningful. Okay? They're not meaningful. So not only do we need them, we want them to be realistic, but we want them to more so to be in the range of the data. So B is our most appropriate answer. Okay, let's look at number 11. It says, in order to predict, you see how we did, we just finished talking about predicting, and so now we're about to do that. In order to predict Y values using the equation of the regression line, what must be true about the correlation coefficient of the variables? Okay, so let's talk about the regression line, the equation of the regression line and what it looks like. If you recall from your math classes in high school, in algebra, the regression line takes on what we call slope-intercept form, which would be, in our calculator, y equals ax plus b. That's the regression line form. The question is saying, in order for me to predict this value, what must be true about R, the correlation between the two? Well, notice that there's no R in here. So it's not about what R has to be to the equation per se. It's about the relationship between the numbers, the quantities. So let's look at the answer choices. The correlation, the word correlation means relationship. The relationship between variables must be a y value on the point of the graph? Not necessarily, because we don't know that. That's not pertinent to this equation. Right here is the violation. The correlation or the association between the two variables, which is really what R is, must be significant. The word significant is meaningful, makes sense. Yes, we want this to be a strong relationship somehow in order for us to predict some values for Y. So when this relationship is strong, then our predictions here make more sense. So far the most correct here is B. And I'm going to put here significant means strong enough to consider. Not stronger. I'm sorry, y'all. Strong enough. Strong enough to consider. And what I mean is the relationship between the two quantities is strong enough. Remember, a strong relationship would either be a closer to -1 or closer to +1 as we can get. Let's look at C. The correlation between the two variables must be a x value on the point of the graph. The same reason A was wrong, C is wrong. The correlation between variables must be greater than 0. Well, that's not true because strong correlations can be negative. Not true. This implies that the correlation is only strong when I'm in the positive values, and that's not true. Okay? Alright, so now we're going to make some predictions. We're going to use this equation of the regression line in problem 12 and make some predictions. I'm going to do all of this on the calculator, y'all. So number 12 says find the equation of the regression line for the given set of data. What is the equation of the regression line? It is y equals ax plus b. Then construct a scatter plot. Well, that's what these little graphs are, and we're going to see that in a moment. Okay, and then draw the regression line. So you technically don't do that. You're just going to be picking out which one is best. Then use the regression line to predict values for each given x value, if meaningful. The number of hours 6 students spent for a test and their scores on the test are shown below. Take a moment to go ahead and enter this into your new list. I'm going to do the same. Alright, so hopefully you've put your data into your list. This will be L1, this will be L2. So let's go in and find the regression, find the equation. So press press stat. Tab over to calc. Remember, we want option 4 and press enter. So here's the equation form. Y equals ax plus b. Here is A and here is B. That's what we're recording, and according to the answer, we should be rounding the slope to 3 decimal places and rounding the y-intercept to 2 decimal places. Well, where are those values? A is the slope. B is the y-intercept. So I'm going to record from my calculator, and here's the space for it. On your platform, these will be drop down or fill in the blanks there, and you'll have an option to put numbers in there. Okay, you don't have to put the X in there. The X is already written for you. So I need to round the slope to 3 decimal places. Okay, the slope is A, so that's 6.376. Okay, 6.376 x. The y-intercept goes here, and I need to round it to 2 decimal places. That would be 35.28. Alright, so there's my equation. Now we're going to, it says choose the correct graph. These are scatter plots. Notice they're scatter plots because the dots look like they're kind of scattered. Your job is to determine which one of these best represents what's happening here in our data. Well, how do I do that? First, I got to look at how the graphs are constructed. I know from the last problem that when my slope is positive, then my line should rise. Well, let's look at these. Clearly that line is not rising. It is falling from the left to the right. This can't be my answer because the line literally is not rising. That can't be correct. Okay? Does that make sense to everyone? That cannot be correct because the line is falling. So that's out. That's a falling line, which would mean it has a negative slope, and that is not representative of our answer. Our answer has a positive slope. What else does that eliminate for us? Hopefully you said answer choice C. It does. It also is falling. It's a negative slope. Okay. Now I have to look at some other indicators from the graph, because now we're down to these two that look very similar. Now I want to analyze this y-intercept. Well, where is that? Here's the y-axis. This is the y-axis. And according to our equation, the y-intercept is 35.28. Well, let's look at the way that the graph is increasing. That goes from 0 to 80. Looks like they're increasing by tens. Let's count. 0, 10, 20, 30, 40, 50, 60, 70, 80. So they're increasing by 10. According to this, the y-intercept is at about 10, 20, 30, at 40. Y'all see that? It's this line right here is right there at 40. Move my hand out the way. That's right there at 40. Well, that's not what this says. This y-intercept, according to this line, is at 40. So the y-intercept is about 40. Well, our y-intercept is at 35.28. Let's look over here at this choice. And let's see if I can make that a little bigger for you, just so we can see what I mean. Okay. So remember, it's increasing by tens. It's 10, 20, 30. That's 30. This is 40. The line is right there in the middle. Y'all see what I mean? My pen is kind of in the way. That's about 35. That's where this line is. I'm going to use my ruler to kind of extend that so we can see it. Y'all see how that is between 30 and 40? But this one was on 40. That's at 40. That means the line is not represented. This one doesn't represent it. This is my better one. Okay? The y-intercept is between 30 and 40. That's more appropriate for me. So I'm choosing that. Y'all see how I had to really look at that graph to determine, and I use this value. That's my y-intercept. That's the y-intercept. This is the slope. Alright, now we're going to use, well, let me take this, make this a little less big. Now let's make some predictions. So we already talked about when we make predictions, we want the values to be meaningful, we want the values to be significant. And so in problem A, it says predict the value of y for x equals 2. Choose the correct answer below. I'm going to demonstrate using that, then I'm going to give you a chance to do that for problem B. So here's my equation. Y equals 6.376 x plus 35.28. They're telling me to use x equals 2. So I'm going to substitute x equals 2 for x. Look at how that looks. 6.376 times 2, I'm using parentheses to denote my multiplication, plus 35.28. So now I go to my calculator, and I'm not trying to enter this in. I just want to enter this in my calculator. Okay? And when I do so, here's what I got. Now I put it in separately. We can where we'll put the whole thing in there. 6.376 times 2 plus 35.28. The calculator knows the order of operations, and it knows what to do first and things like that. So look at my answer, 48.032. I'm going to look here. Notice how I see my answer, but I also see this phrase, not meaningful. Well, what does meaningful mean? It means that my x values have to be significant. When I make predictions for y, my x values have to be significant. They need to be as close to the data set or in the range of the data set. Well, let's look at my data set for x. 1, 2, 3, 5, and our x was 2, so that's meaningful. So our answer, 48.032, puts us right here at B, 48.0. I'm not choosing not meaningful because 2 is in the range of my x value. So my answer is, my prediction is good. Let's go here to B. Before we even look at it, will our prediction for y be meaningful or not meaningful? How do I know, Miss Thomas? I know that because my x value is significant to the data. It ain't far out. My x values were like 1, 2, 3, 4, 3, and 5. That's within that set. So when I get my answer, it should be one of these, not this one. Okay, let's look at it. Let's calculate it. Y equals 6.376 times 2.5 plus 35.28. Okay, let's do that. 6.376 times 2.5 plus 35.28. 51.22 is what I'm going to record here. Y equals 51.22, which is the most appropriate right there at A. Is this prediction meaningful? Yes. Why is it meaningful? Because 2.5 is significant to the data. Alright, let's look at C. Predict the value of y for x equals 15. Choose the correct answer. Do I need to even do this? You should be saying no, Miss Thomas, because this is too far. This value is not significant to the data. It's an outlier. So if it's not, this is 15. All the x values were one digit, low one digit, 1, 2, 5, and here I have 15. That means I'm gonna get an answer, and if you do this, you will get an answer, and it's listed here, but it's not meaningful because the x value is not close in the range of the given x values. So I don't even have to calculate that. But for the sake of showing you, let's look at it because I want you to see how tricky they will put this. Okay, 6.376 times 15 plus 35.28. You see that answer? There it is. But it's not meaningful because the x value was too big. It was too far. Y'all see where I'm putting my pen. The x value is too big. Okay, so it's not meaningful. Alright, D. Let's look at the x value. Predict the value of y for x equals 1.5. Do I even need to consider this? Yes, I do, because this is a significant value to the data set. So let's do this problem. Y equals 6.376 times 1.5 plus 35.28. Y equals, let's do that, 6.376 times 1.5 plus 35.28. $44.844. And I'm going to record right here 44.8. Alright. Number 13 is very much like number 12. I'm not going to do number 13, but I will give the answers. I would suggest you try number 13 on your own to try to come up with that answer. If you have trouble and you want to, like, you just want to check yours to see where if you got stuck or something, then you just let me know. You can send me an email. So for the sake of time, our linear regression line, you should get y is equal to negative 0.20x plus 6.54. I'm going to write that over here. Y equals negative 0.20x plus 6.54. Okay. Here, just like in number 12, you have to determine which one is best. Notice how here I have a negative value for my slope. So all of my lines should be falling. This is falling. This is falling. This is not even linear. Can't be my answer. Not linear. This is not a falling line. Y'all see it is right here. It's horizontal. Can't be my answer. It's horizontal. The fact that I have a slope means that it would not be horizontal. So that leaves me here. Okay. And for the sake of time, A should be your answer. You use your same process that we use in number 12 to determine our graph. Okay. All right. Here, they're saying predict the ERA for 5 wins. That's your X. You're going to use that value into your equation. Okay. Use that into the equation. Now, and we're getting that from here. Here's the data. I'm sorry, I should have said that. The data is here. I almost got confused. Here's the data. In answer to in question A, it says for 5 wins. Is 5 significant to this data? Does it fall in the range? Hopefully you're saying no, Miss Thomas, it doesn't, because the lowest number is a 9. So what does that mean? That means that this is not going to be significant. Because it's outside of the original data range. What about for 10? X is equal to 10. It's my X value. X is equal to 10. Well, that's in the data range, right? 10 is in the data range, so we can find that value. Okay? And so Y should be equal to about 4.59. Use what we did in number 12 as a guide. All right. 19, is 19 a do you think 19 would be significant to the data? I think so as well, because the data runs from 9 to 20. So 19 would be significant. That's our X. So I'm going to give you a moment. I'll pause. I'll give you a moment to try that. I would suggest you pause the video, try it on your own. You should get about 2.83. This is a significant value. X is significant in part B as well. 15, is it significant? Yes, it is significant. Because this value is within the range of the data. And you should get 3.61. Okay. All right. Okay. This is number oh, this is a different problem, y'all. I'm sorry. Let me see. Let me make sure. We should be on number 14 now. I'm not sure why that okay, so disregard this right here, y'all. This is the date. Disregard this part. Okay. Number 14 is on the next page. This is the data for number 14. Data for number 14. Okay. So let's look at the data. We're comparing shoe sizes to height. The range of the shoe sizes look like they run from 8.5 to 12.5. So when I think about what will be significant, it will be numbers that fall within 8.5 and 12.5. Okay, so that's how I want to even go ahead and get in my mind that significant predictions for Y have to have an X value that fall in this range. All right, so let's look at the context. It says the accompanying data are shoe sizes and height inches for 14 men. Find the equation of the regression line, then construct a scatter plot, then use the regression line to predict the value of Y for each of the given values if meaningful. If the X value is not meaningful to predict the value of Y, explain why not. Okay? Look at all of your X values, y'all. So the first thing is you have to find the regression line. That means you're going to use your table that's on the previous page to do your calculator method. So right here, to find the regression line, you need to use the calculator. The same keystrokes we've done for a regression line before. The data is on the previous page. Now, it says we're going to predict values for Y with these given values for X. Okay. But look at how. So for the value of 11.5, I want to talk about significance. 11.5 is 11.5 in the range of the X values for the data. You go back and look. Here's the data. Is 11.5 within that range? It is. That means you can find an answer for that. So it is significant. Okay. Look at B. 8.0 is the data. Is 8.0 significant, y'all? Yeah. Even though this is 8.5, but 8 is not far from that. So yes, that also would be significant. That means you can find an answer. You can find an answer for it. C. 15.5. Is that meaningful? Is that a significant value? Hopefully you said no, Miss Thomas, it is not. You're right. Here's the data. You might be saying, well, why was 8 significant but 15.5 is not? 8 is not far. It's just a half off. But 15.5 is a full 3 sizes away from 12. That's too far. That's an outlier. That's too far from the range. So for C, 15.5 is not significant. Well, tell me, what does that mean to my prediction? If 15.5 is not significant, you should be saying, well, Miss Thomas, my prediction will not be meaningful. The prediction is not meaningful. So let's look at this answer choice, meaningful. Okay, I'm gonna flip over. Let's look at this answer choice. Where is the answer choice? Sorry, y'all. Oh, that's what it is. I got it, y'all. I'm sorry. So what I told y'all to cross out, it is number 14. My mistake. So here's number, this is the rest of number 14, y'all. I'm sorry. So B, it is not meaningful because x equals 15 is not an x value in the original data. Let's go ahead and highlight that. I apologize for that mistake, y'all. And then look, 10, is that significant? Is that a significant value? It is. So this is significant. And what does significant mean to us for my work? It means that my prediction will be meaningful. I will get an answer. You need to calculate that. I'm going to give those answers to you. Calculate them on your own. This should be 70.16. Okay, I'm going to go back and give that answer for here. For part A, you should get 72.75, and for B, you should get 66.71. Okay. Now let's go back to this part here. Remember, once you when you get your regression line from your calculator, you gotta make sure you use your calculator. You should get y equals 1.73x plus 52.88. I notice that my slope is positive, so I'm only going to consider these two graphs. There's not even a line in this one. Can't be right. No regression line. This one's not even linear, and regression lines are linear, not linear. So now I have to consider which one is better. Okay, well, do you all see that this one, now I'm comparing this y-intercept, this part is a positive 52.8. I'm going to use my ruler to extend it because I can't see where this line comes our way out to the graph, but I do see, y'all, I'm going to make this bigger. I do notice that I want to get really close to 52, almost 53, and this is 65. So what y'all think? Here's the line. If this is 65, this line is really close to 65, but I need 52, almost 53. Which one would be better? This one is down here. Look, you see this squiggly part? So this one is definitely below 65, but this one way down below 65. I would estimate that to be like in the 20s, y'all. So though they're both far from it, like it doesn't look like it, this is actually my better one, because even though it's closer to 65, it's not as far away as this one is. So the better line of regression, or the better scatter plot, lives in Answer choice B. Okay. All right. I'm going to stop there. Number 15 is done very similar to all of them. Okay. And all you're asked for in number 15 is that equation. Let me go ahead and give that to you. 6y equals 654. Notice 0.00, those two decimal values mean something. It's significant there. This one has a negative y-intercept, so I need to record that. Negative 1,212.71. So it would look like this, y'all. Minus 1,212.71. Okay. Email me if you have any questions, need anything clarified. Put your question in the email when you're emailing me about any questions about this. You can also bring your questions on next week. We'll take about 5 minutes to go over any questions from sections 2.1 and 2.2 before we start 3.1 on Tuesday. Thank you guys. Have a great day.